Hey ladies, for those of you absent today, just wanted to make a quick video since we're nearing the end of the semester. Today in class we did 2 worksheets over ellipses. Very similar concepts to what we learned a couple days ago, except it does include a couple new vocabulary terms that I just want to go over really quickly. So the first worksheet you got looks like this one here, and it's just some reviews of graphing. There's 8 of them. A little bit of terminology that I want to give you is if I was to draw an ellipse, any ellipse, right, looks like this. Okay, obviously we could tell that one axis is going to be longer than the other. So this one here is going to be my long axis. This is the larger one. And because this is the larger one, we call it a major axis. Okay, on a major axis lies vertices. So we have vertices. Now on the smaller axis, like this one, and my drawing's not the best, but you get the point. On this smaller axis, this is called a minor axis. And on a minor axis, we have 2 co-vertices. So when we do the worksheet and it asks us, well, what are the vertices and what are the co-vertices? The vertices lie on the longer line and the co-vertices lie on the shorter line. Okay, so I'd kind of pause this, get this written down so you have all this terminology. And now I'm going to go ahead and erase it. And we're going to do a couple of these. I'll do a couple with you, and then you're going to do the rest of them on your own. Okay? So as we graph, the first thing we need to do is look at the center. And we see that we just have an x squared and a y squared, nothing added or subtracted. So my center is 0, 0. Now, underneath my x squared, this is going to give me the longer line. Okay? So my vertices are going to go left and right. And then my co-vertices are going to go up and down. So the first thing I'm going to do is plot my center. Underneath x squared is 16. The square root of that is 4. So I'm going to go 4 units to the left and 4 units to the right. This is negative 4, 0. And this is 4, 0. When I look at my 4, the square root of that is 2. So I'm going to go up 2, and I'm going to go down 2. The coordinates for that are 0, 2, and 0, negative 2. So at this point, I can now draw my ellipse. Okay? From the ellipse, we have to recognize what are our vertices. Remember, the vertices lie on the major axis, so they're going to be on this long axis here. So my vertices are negative 4, 0, and 4, 0. My co-vertices are 0, 2, and 0, negative 2. Okay, so you're going to do 1, 2, 3, and 4. When you look at number 4, it's not in standard form. So we're going to write it in standard form, right? We have to add that 5y squared to both sides. So I have 7x squared plus 5y squared is equal to 35. And we know that every equation has to equal 1. So I can go ahead and divide by 35. And it looks nice, except for when I reduce. I have 1/5, so 1x squared over 5 plus y squared over 7 is equal to 1. And I'm going to go ahead and get rid of that 1 in front of the x squared because we're not used to seeing that. Okay, now the only problem with this is that these numbers here, 5 and 7, these are not perfect squares, which is okay. Right? You know that you're going to find the square root. And so in our coordinates here, you're going to write the square root. But then when we plot it, we're just going to approximate. So our center is 0, 0. Now we have to find the square root of 5. So if you put that in your calculator, you get like 2.2-ish. So that tells me let's go 2.2-ish to the right. Oh, that's not 2.2. That's 1.2. And about 2.2-ish to the left. Okay? And that is smaller than the 7, so it's going to be a co-vertices. I went root 5, comma 0, and I went negative root 5, comma 0. Now my vertices is the square root of 7, which is about 2.65. Right, so I went over 0 up root 7, and I went over 0 down root 7. It looks like a circle, but it's not. My y axis right here is longer. Okay, the last one I wanted to do with you before you worked on these is number 5. So we take a look at number 5. The first thing we have to do is identify our center. So because we have a negative 2 here, we know that our center is a positive 2. And we have a negative 1, minus 1, so we know our center is a positive 1. So our center is over 2, up 1. Now, I'm going to plot all the points on my graph first. I see that under the x is 9, and that's still always, x is always left, right. And the square root of 9 is 3. So I'm going to go 1, 2, 3 to the right, 1, 2, 3 to the left. Square root of 4 is 2, and under my y is always the up, down. So I'm going to go 2 up, and I'm going to go 2 down. Okay, and I can go ahead and I can draw my ellipse. Now the part that was a little tricky for everyone in class is our center is not 0, 0. So when you find your vertices and your co-vertices, you have to count by using the coordinate grid. So let's zoom in here. This is going to be my major axis because it's longer. So these yellow points, these are my vertices. And the one on the left, started at the origin, I went left 1, up 1, so negative 1, 1. Starting at the origin, I went right 1, 2, 3, 4, 5, up 1. And I went to 5, 1. So those are my vertices. Negative 1, 1, and 5, 1. My co-vertices are in a similar manner. I start at my 0, 0, and I go over 1, 2, up 1, 2, 3. So that's at 2, 3. And then this one is over 2 and down 1. This is at 2, negative 1. So when you look at your other ones that you've done, numbers 1 through 4, a lot of these have zeros in the vertices, right? Either for their x coordinate or their y. And it's because their center was at 0, 0. Now your center's not at 0, 0, so you don't have the zeros in your vertices per se. Okay, the rest of these should be pretty easy. If you take a look at number 7, when you divide everything by 16, don't forget about that number 4 here. You're going to have to simplify. Okay, and then on the back side, you have a little bit of work to do. And when we take a look at some of these, the vertices and the co-vertices, right? It kind of helps you identify what's the x, what's the y. We know that when it is a 10 and negative 10, that these are 10 spots away from the center, and that's larger than 9 spots away from the center. Right? Moving 10 to the right and up 0 is going to be our x value. And so we know that these are under our x's. Co-vertices under our y's. Okay, same thing for number 2. When I look at my vertices and it's over 0 up 6 and over 0 down 6, this is up and down, so that's my y. When I go 5 to the right and 5 to the left, that's left and right, that's going to be your x's. Okay, so from the center, we went 6 up. 6 squared is 36. From the center, we went 5 to the right. 5 squared is 25. And you should be able to write that equation. All right, this next problem is a good one. It gives you just the height and it gives you just the width. So when they give you the height, starting at the center, which you already know, so you should be able to write that top part of your equation, right, pretty quickly. You just need to figure out what number goes underneath. So if the height is 18, that means it's the whole height. So 1/2 of it has to be 9. And the other half is 9. So from the center to that endpoint, it's 9. And 9 squared is 81. And 81 is going up and down. So that goes under my y. Right? Up and down. The width is 14. Half of 14 is 7. 7 squared is 49, and it goes under my x because it's going left and right. So these are just application problems of all of the ellipse stuff that we have been working on. So 25, first thing you have to do, we have to find our center. So let's look and see what looks like the longest line across the center. Right there. And this looks like the longest line. So where these two intersect is the center. I know this side should be congruent to this side and there congruent to there. And when you count from the center up 1, 2, 3, 4, 5, and you count down, both are 5. You count left, you have 6, you count right, 6. And now go ahead and write yourself an equation. Use the center coordinate, right? -1, -1. And then you can see your width, your left and right, which goes under the x. And then you can see the up and down, which is under the y. All right, there you go. The last two. Number 24 is nice and easy. You can do that one. Number 23 is very similar to number 20, where they do not give you the distance, but they give you the endpoints, right? So if the major is over 4 and up 18 and over 4 and down 4, you can see that they go straight up and down on the 4. Right, this number is the same. The minor axis is over 12 and up 7, and left 4 and up 7. And you can see here the 7s are the same, so it's straight across. All right, 3 things you're going to need in order to do this. You're going to need to know what's the center point. So you're going to need the midpoint formula, right? You can find the midpoint of these two. Or you could find the midpoint of these two because it should be the exact same. So find the center, and then you need to find the distance. What's the distance left and right to go under the x's? And then what's the distance up and down? And then you'll get it. All right, ladies, have a great weekend. I'll see you next week. Bye.